So there's lots of more metrics and lots of more charts available in the white paper. So if you're interested, then please have a look at that. But let's look at some of the different parameters that you might want to try in your tools if you are interested in the fast speed fuzzing. And if you don't see some of these features in your tools, then please contact us, and we'll see if those capabilities are not available for all of the tools yet, or maybe there's a version that you need to ask separately from us. But anyways, command line usage is something that I think in one customer questionnaire we did, it was almost half of our customers using our tools in GUI and half of them from command line. So command line usage often seems like it will make your tool run faster. And that's really the fact with most of the fuzzers. But when you actually try in your own setup, you can actually often see that GUI can be even faster than command line usage. And the reason is with this architecture that we have in our tool, so the GUI is really just a supervisor of test execution, and all the tools are already optimized in the execution, so that the difference between running our tools on command line and GUI is actually quite insignificant, and often actually can be exactly the opposite. So in my setup, which is a very bad example of using our tools, but using a low-end dual-core Intel Mac with pure default settings, I noticed that the command line execution was actually significantly slower than using it from the graphical user interface. Looping a valid case, which is like performance testing setup, was almost like 10% faster using the GUI, and enabling you actually to use lots of the parallel setups that might be more problematic to use from the command line. Every feature is available from the command line, but this setup using the GUI actually doesn't really slow down the test execution. Most people use our command line tools because they need to automate tests, and if you want to run like 100 separate parallel processes, test generators, then of course the easiest way to do that is using command line. If you only need to run 2 or 3 different protocols in parallel, or instances of the same protocol in parallel, then you are perfectly fine with using the GUI setup as well. When you are running fuzzers in parallel, the GUI has options so that you can load lots of different protocol models, and then in the main panel you can select execute sequence or execute parallel, and with that you can either focus on testing different test scenarios individually, or you can build lots of different test scenarios and execute them in parallel and see how they actually impact each other. An easy setup would be, for example, to have one of these instances running a valid case in a very busy loop, creating a regular load on the test target, and then do it using the other test suite to actually run the fuzz tests against the target. Another one would be to just have a number of test generators running in parallel, and each one of them, for example, using a random test order. And with that kind of setup, you can potentially find issues that would be very hard to find with a sequential order of test cases. Again, using it on the same low-end dual-core setup, even there, using 2 setups in parallel instead of just one test generator gave immediately like 50% up to 100% speed improvement in the test execution. When you have lots of hardware resources, the speed increase should be completely linear. So the more test generators you have, the more test cases you will execute per second, until a resource like memory, CPU, or network resources from the operating system start to run out, or physical restrictions are met with the network interface. Until that time, the more test generators you run in parallel, the faster your tests will execute. The multi-threaded mode is a test feature that we have been testing just for some specific setups where you don't have enough some of the hardware resources. The best benefit from multi-threaded mode is that it uses less memory. So dividing tests between test drivers inside each one of those processes still consumes the same amount of memory, no matter how many threads you create, but the test execution and the analysis of the test results understandably becomes a bit more challenging, because when you have the same test engine using and sharing the test cases between lots of threads, there's bound to be some issues with that kind of setup. So of course, the optimal setup is really running test processes in parallel instead of running threads in parallel. But when you don't have enough memory to run lots of processes, then it's best to use the execution threads mode instead. This feature is already in some of our release tools, and hopefully will come out in many more. And that will enable you to run lots of parallel fast test cases even with a single test suite. Let's next look at some of these features in a live setup. So what I have here running is a Defense 3 latest 3.11 2 and the HTTP server test suite, which was probably released just like yesterday or 2 days ago. And here you can see the multi-threaded capability on the GUI itself. So it's a default feature on the tools, and it's not anything you need to pay extra for, or, well, you have to ask your account manager for that. But anyways, it is a default feature in all tools which are enabled to use multi-threaded mode. I have a virtual Linux server running on the same host, and again, this is just a dual-core computer, so we won't see huge high-performance examples here. You have to try those at home. Or you can look at the white paper to see examples of our tests with the high-end server platforms. But we can still do simple tests. So the only special configuration I have in this setup is under the instrumentation, and I am running an option repeat test case and 10,000 times. So in this example, we are running a valid case, which you can see under test cases, just one single valid case, 10,000 times in a loop and in single threaded mode. And if I execute this, it should take approximately less than a minute or so to run those 10,000 valid requests against the Apache web server running on the Linux server. So, and the reason why I'm using 10,000 test cases instead of 1,000 is that you can see the time differences much more effectively. If you use a very short volume of test cases, the differences between those executions are disturbed by the test generation and the time it takes to load the actual engine and the test suite and so on. So in your own measurements also try to select a representative amount of test cases so that you can actually estimate how much speed improvement you get from that. So again,